Hi guys, purpose of this video is to show you or to help you in writing ionic formulae. We've got another video on that as well earlier, but this one is more around the complex ones. The ones that are a little bit trickier. The ones that are going to be using these things called polyatomic ions, which we've talked about again in a previous video. So let's get started. So we've got a list here of ionic compounds. So remember, ionic compounds are compounds that have positive and negative particles that are stuck together or by electrostatic attraction because we have positive ions, which are the metals, so aluminium, sodium, ammonium, etc. We've got our positive ions in the front. They are ions that have lost electrons, and we've got our negative anions that are second, that they have gained electrons. And so they have positive charges and negative charges, and that holds them together. They attract each other and they form these crystal structures. So chemists don't like to write their names all the time. They like to write their formulae so that we can write chemical equations and things like that. So the purpose of this video is to show you how to write those formulae using some more complex polyatomic ions as well. So first step is always to find that we're going to do number one here, aluminium chloride. We've got to write the aluminium's ion. Okay, so we can go over here to our common ions table and we can find aluminium. So aluminium is here. Hopefully this is going to draw. There we are. So there's aluminium. So we can come up here and write, well, we know aluminium is Al and he has a 3+ charge. Now we've got to go and find the chloride ion. So he'll be the anion. So we find the anion list, the negative ions. And where is he? There he is, chloride. So he's got a -1 charge. Remember, you can deduce him off the periodic table because he's in group 7 and needs 1 extra electron to fill out a shell. So there's our 2 ions. Okay, so aluminium chloride is, and we're going to write them out now, aluminium 3+, and they're going to come together plus with the chloride ion, which is -1. Now we want to write the formula. These are the 2 ions that are going to get together and form the bond, but we want to write the formula for those. Now remember, the key here is that the number of charges, the positive charges that we have here, needs to be balanced by the negative charges from the anion. So we can't have an uneven number of positive charges and negative charges. At the moment, in this case, we do. We have 3 positive charges and we have 1 negative charge. So at the moment, we don't actually have we can't write the formula just AlCl because the charges are not balanced. We've got too many positive charges. We've got 3. We've only got 1 negative. So we need more negative charges to balance out this 3+ charge here. The only one that can contribute these are the chlorides. And so we've got 1 negative charge. We need 3 negative charges. So we're going to need to actually have 3 chloride ions bond with 1 aluminium. So this big 3 at the front just says that we need 3 of the chloride ions to bond with we could even put a 1 here if we wanted, 1 aluminium. If we do that, that 3 says, I'll draw it up here for the first time, that 3 says we've got 1, 2, 3 chlorides. And the 1 here we have 1 aluminium. Now if we've got 3 chlorides, we've got -1, -2, we've got a -3 charge overall. And we've got a +3 charge on this side, and so those guys cancel out. And that's what we want. So we actually have to have 3 chlorides in this compound for every 1 aluminium. That's its simplest ratio. So over on this side, we're going to write the formula. Now we don't put a big 3 in the front, so we don't do this. Okay? We always, whenever we're writing a formula like this, and we need more of a particular atom or ion, we put a little 3 down the bottom in this case. So this here is aluminium chloride. Aluminium chloride, 1 aluminium, 3 chloride ions. They come together and form a crystal structure. Alright, let's try the next one. Aluminium oxide. So we know aluminium is 3+. We find our oxide ion over in our table, and we'll find that he is there. So he is oxygen 2- charge. So now we write our ions out, Al3+ plus O 2-. And they're going to come together to form their compound, the ionic compound. Remember, the charges have got a balance. Now this is a little bit trickier. There's 3 positive charges here and 2 negative charges here. So they don't balance. We've got an extra positive, so it's not going to work. So we've got Al and O, but we have to balance the charges, so we have to do some work here. Now, the easiest way to do This is not as simple as just going, we need an extra oxygen or we need an extra aluminium here. These numbers don't really work together well. The trick here with these sort of numbers is to think about what's the common factor. What's the smallest number that both of these charges will go into? So what is a common factor of 3 and 2? What will 3 go into and what will 2 go into? What's the smallest number? And the answer there is 6. So if we want to, how many times if 3 will go into 6, 2 times. So if we put a big 2 out the front, we will have 2 aluminiums, and each of them, that gives us a total of plus 6 in terms of the charges, because we've got 2 aluminium atoms, each with a positive 3 charge, so we've got positive 6 charges overall. Now, how many times does 2 go into 6? Well, it goes 3 times. And so if we do 3 times 2, we have negative 6 charges over here. So can you see how that's helped us balance the charges? We've now got 6 positive charges brought from 2 aluminiums, and we've also got 3 negative 2 oxides, which gives us a negative 6 charge as well. So these guys now are balanced. We're happy. It's a tick. So we come over here to our formula now, and we write, we need, for this aluminium oxide, we need 2 aluminiums. So we need 2. The little 2 refers to the aluminium only. And we need 3 oxides. So we put a 3 in there. So that's the formula for aluminium oxide. I'm just going to get rid of this so we can do the next one. Sodium nitrate. Let's have a look at this, guys. So sodium, if we check the table, is Na+, and nitrate. Now nitrate here is our first polyatomic ion. He's a bit tricky. We looked at that in a previous video. So we find our polyatomic ions, polyatomic, many atoms. Find our nitrate. Here he is. So our nitrate is actually NO3-. So remember, don't get too confused here. Only look at the charges. The charges is what we care about. So now we're going to write our ions out. Our cation, Na+, plus our anion, which is our negative ion, which is NO3-. Now to write the formula for sodium nitrate, we need to balance the charges. Now we can see in this case we've got 1 positive charge here and 1 negative charge here. That's what we've got. They're balanced already. Don't worry about the little 3. Remember, this just tells us about the structure of that polyatomic ion. That's just what the particle looks like. When we're writing these formulae, we only care about balancing the charges. So we can come over here and just write Na. We only need 1 Na, and we need 1 nitrate, the whole thing. So NO3, that is a nitrate. And that's balanced. We don't need to write anything else because they've balanced the charges. Let's go to sodium sulfate, Na+. And now sulfate, again, polyatomic ion. Go to your table, and we look down and we try and find him. You'll probably find him before me. There he is, sulfate, SO4. Oops. There he is there anyway. My pen has decided to stop working. Okay, I think my pen's back. Hopefully, there it is. So sulfate is there, SO4, 2-. So we're going to take those ions and write them next to each other. Na+, plus sulfate ion, SO4, 2- this time. So now these 2 ions are going to come together. They're going to bond together, again, because of their difference in charges, and going to form the compound, sodium sulfate. But remember, we've got to check that the charges balance, and in this case they don't. We've got 2 negative charges and we've only got 1 positive charge. That means we're going to need another positive charge. So we need to have 2 sodiums. 2 sodiums means we have 2 positive charges. So I'll put that in there, 2 positives. And we've got 2 negative from the sulfate, so now they're balanced. We're happy. So over here we need to make sure that in the formula we tell the reader that sodium sulfate, in the sodium sulfate molecule or compound, there's actually 2 sodiums. That 2 refers to just the sodium, not the sulfate. So we put the little 2 after the element that we're talking about. So that there is sodium sulfate, Na2SO4. All right. Last couple of ones. Ammonium phosphate. Now ammonium is, again, polyatomic. So we go and look for the word ammonium. There he is. So he's NH4+, and phosphate is another one, PO4, 3-. So it's a bit tricky. So we're going to write those in, NH4+ plus a phosphate, PO4, 3-. Alright, so again, polyatomic ions, but we need to balance the charges. Plus 1 plus and 3 minuses. We've got too many minuses. We need some more positive ions. How many do we need? Well, we need 3 positive ions. So I'm going to put a big 3 in front. That will balance our 3 negative charges here. So we come over and we write our ammonium now, NH4. And we need 3 of them. Now this is the trick, right? This is the bit where it gets a little bit tricky with polyatomic ions. We need 3 of ammonium ions, 3 of the whole thing. And remember, ammonium is NH4. That's what ammonium is. The whole thing is ammonium, so we're going to put it in brackets because we need 3 of the whole thing. Whatever's in the brackets, we have 3 of those. We have 3 ammoniums, so we have to put the ammonium, every time you need more than 1 polyatomic ion, you need to put them in brackets. Because if you don't, then you just got a 4 next to a 3, and it's complicated, and it's weird, and it doesn't work. So the brackets tell us that we need 3 of what's ever in the brackets to balance out the phosphate, PO4. So this is ammonium phosphate. Ammonium phosphate is a crystal, an ionic crystal that contains 3 ammoniums for every 1 phosphate molecule. Looks complicated, looks weird, but remember it's just cations, positive ions, and negative ions, just like before. All right, one more practice. Aluminium, sulfate, Al3 plus, and sulfate, SO4, 2 minus. Remember, you can always look up these charges in the table if you can't remember them. So let's write them in. Aluminium ion plus a sulfate ion. Now, a little bit tricky. 3 positive charges and 2 negative charges. So we're not balanced, so we have to do some balancing of those charges to make sure that the ratios are correct. Again, we got those numbers that don't really work very well, 3 and 2. They don't go together very well. So remember, we do the whole little trick where we go, what's the common factor that 3 and 2 both go into? What's a number that 3 and 2 both go into? And we know that number from the previous questions is 6. Okay, so we're going to turn these into 6. So how many times does 3 go into 6? It goes in 2 times. So if we have 2 aluminiums, that means we have a total of 6 positive charges. Now, how many times does 2 go into 6? 3 times. So 3 times negative 2. We have a total of 6 negative charges, which is good. Again, we've balanced our charges. Overall, they're 0. 6 plus, 6 minus equals 0, so we're happy. And so now we've got to write our formula. We've got aluminium ions, and we've got 2 of them. So we put a little 2 down the bottom. And now we've got 3 sulfates. Now remember, sulfate is a polyatomic ion, so we have to put it in brackets. So SO4 is the sulfate, and how many do we need of them? We need 3. So we put them out the outside. This is about as hard as it gets, writing ionic formulae. Okay, we've got polyatomic ions, we've got a little bit, the numbers don't quite match up. This is as hard as it gets. This formula is aluminium sulfate. Okay, he's an ionic crystal. We've got the metal, we've got the non-metal, but we've got, for every 2 aluminiums, we need 3 sulfates, and that means that the charges will be balanced. And our ionic crystal is neutral overall, and that's how he exists in the real world. All right, well, I hope that's helpful. We'll give you some practice on those. They're a bit tricky, but I hope that's good stuff. Thanks, guys.